Hey, this is the as my kids call me affectionately, the Dirt Doctor, Brian Hopkins. Talking about site assessment today. I kind of got my first opportunity at site assessment as a PhD student when I was at Kansas State University. I earned my master's degree and bachelor's degrees from Brigham Young University, but went to Kansas State to manage their soil testing lab full time and work on a PhD part time. And I got this call from a county extension agent down in southwestern Kansas. Pizza Hut Corporation was having problems in their landscape and needed some help. So they had me come down and give them a hand. I got there and within about 3 minutes solved the problem. Not that I'm not that smart, but I just didn't do due diligence before I left. If I'd asked the right questions, I could have saved them and me that trip and solved the problem without as much trouble. So I've learned some things about site assessment. So I'm just going to kind of talk about that in terms of how how to assess a site. Let me share my screen here. So I like to think about sort of where I exist in the world professionally in terms of soil science and management, in terms of this three-way interaction between physics, chemistry, and biology. And plants have that interaction. I mean, all these things go together. And so it's important to factor all of these types of things in to our management when we're working with plants. So I think we need more of this. I think too many of us, especially in the green industry, the urban environment, got a lot of folks who love plants, they love flowers, but soil is just this nerdy thing that I do. But boy, it's really important. The soil is critical. It's so important to understand what's happening down there. That's not the only thing that's important, but it's certainly part of the picture. So what I've learned over the years is, first of all, we know exactly what plants need. It's not a big surprise. I have a list and it's complete. I've also learned though that snake oils are only good for snakes. We get a lot of folks who are trying to apply some black box principle. Put the snake oil on to solve your problems, and most of the time that doesn't work. What we need to do is we need to understand the basics, go back to the basics when we're trying to do troubleshooting and when we're managing plants in a soil environment. So the question is, what do plants need to live, or to think about that in terms of how do they thrive? I've been accused of looking like the couch potato Homer Simpson. He's certainly alive. He may not be thriving. We contrast that to a healthier lifestyle for humans. It's an interesting parallel with plants. And if we think about that, what do plants need to thrive? We see these plants here doing this research study with one of my former students, Beth Black. We were looking at nitrogen in turf grass. You can see there on the left, that's incredibly healthy Kentucky bluegrass. Those roots are deeper than what we see in nature. I never see roots that deep with mowed Kentucky bluegrass. But here we are in this artificial environment. We've provided everything those plants need artificially in this situation. And look, they're doing great. So again, we understand everything we need to help plants live and even thrive. But by the way, those plants on the right have too much nitrogen, a little greener, a little more growth, but look at the negative impact on those roots. So it's good to understand the science behind these things and be able to manage them appropriately. So wait a minute, you say, we're talking about soils and you're telling me we don't even need soil? Well, not really. I mean, plants don't have to have soil because those plants I just showed you growing hydroponically, no soil involved. Now, in nature, we obviously need soil because it's a vehicle to provide much of what we need for those plants. So what do we need? What's that list? Well, first of all, we need nutrients and water. We have non-mineral nutrients, hydrogen, carbon, oxygen. Plants need a lot of that. Majority of the plant and us, organisms are made up mostly of these three, but they're ubiquitous in the environment. We aren't deficient of these in nature. These are things that are important for us, for plants, but do I need to support them, supply them? No. Now, mineral nutrients need to supply those, nitrogen, for example, as we showed in the previous slide. We also have needs for a proper environment. It's important to have the right temperature, humidity, need precip, or providing that artificially through irrigation. We need the right energy. You have to have good light intensity. Plants have to have that, and the right day length. That's important, especially for some species. Root zone pH would be another example of proper environment. You can see here on the right, this picture of some roots that were growing at pH 6.5, which we've been taught that is ideal. Contrast that to the acidic pHs of 5.2 and 5.5, where we have some toxicities that are harming the plant root growth. We also need the absence of toxins, such as in this picture on the right, we've got a fertilizer spill from a drop spreader that stopped 3 or 4 times here, and some fertilizer spilled through the holes in the drop spreader, and it killed the plants, showing that, salts, plants need salts, but too much salt, not good. We also have specific ion toxicities. All those things like too much nitrogen, it can be toxic. Some things are even more toxic, like copper, or chloride. Again, essential nutrients, just like nitrogen, but I get too much of those and I get into problems, specific ion toxicities. We also need an absence of xenobiotics, toxic ones, such as pesticides. I mean, that's a good example. I get, plants can potentially tolerate some pesticides, but if I get too much or the wrong ones, I can have those chemicals can kill plants. I also need minimal pest pressure. Microbes are important for plant health, but I get pathogenic microbes. They can harm plants if I get them in populations that are too high. Same thing with insects and other macrobes, and then also weeds. Soil is involved in all of these. It's not exclusive, but it's certainly a part of every one of these things. We need to understand how that works. So now when I go to site assessment, when I get stumped on solving a plant problem, or I'm trying to consider some new product or some practice, I try to align it with these things and try to think about, what do plants need? That really helps me. If I kind of go down that list of what plants need and sort of start asking myself the questions, if I got an unhealthy plant, what's missing or what's the problem here? I'm usually able to kind of narrow that down, and it helps me think through troubleshooting situations. So I asked this question, how does whatever I'm considering fit with what we know about what plants need, and how does the soil provide those things in the case of soil related issues? Another thing too is what is the genetic potential? Like I said here on the graphs here on the left, we're typically not meeting the genetic potential of what's out there because of limitations in the environment. We can do a better job if we manage things properly. Now, I can't reach that genetic potential unless all of these things are optimal, or at least in a tolerable state, in order to make plants be happy and thrive. Also, you can't manage effectively what you don't measure. So the question becomes, which of these things should I be managing, and how do I measure how I'm doing on that? Stay tuned for that for another video. We'll talk about that later, but those are good questions that need to be asked in terms of managing, and we'll do that again another day. I do want to go back to this list. I want to pull up this, whoops. Here's my list that I referred to initially that I've kind of developed over the years. When I go do an on-location site assessment, I think it's good to pull this list out and try to think through things. We've got a list of things to consider before I show up, to avoid my Pizza Hut experience. Determine the following, get this information from various sources. I need to obtain the following based on the situation, maps, for example. Here's some additional things that I need to potentially obtain. I wouldn't necessarily get all of these things every time, but these are things that I potentially would need to take with me for an on-site assessment. I've showed up several times in my life and wished I had had a certain tool. So that's my list that I've developed over the years. Now, during the visit, there's things to consider as well, things that I should be doing. After the visit, there's some considerations as well. Now, I'm usually taking soil samples and or plant tissue samples, also water as well, similar principles here, but here's just some basic guidelines. You can Google guidelines on how to take samples, but here's just some rough ideas of things that you need to know in order to do an on-site assessment with regard to soil and plant tissue sampling. So thank you very much. Hopefully this is helpful in your quest to do on-site assessments.